Hi everyone, welcome to the first programming installment of my tutorial on how to make your first game. I'm going to focus on setting up our canvas and getting a character on the screen that our player can control. This is what it's going to look like by the end, and we can move our little black square here left and right using the arrow keys. The canvas element has been around since the mid-2000s and started getting traction being supported by all major browsers after a major update to HTML5 in 2014. The way it handles drawing 2D graphics is really similar to a lot of other 2D graphics APIs, or application programming interfaces. Usually, these APIs also handle creating a window for whatever operating system the user is running, but HTML runs in a web browser, so we don't have to worry about creating a window. We can just open our game with Chrome, Firefox, or whatever your browser of choice might be. We're just going to make a web page with a canvas in it, and then we'll use JavaScript to change what displays on the canvas. So let's get started by making that web page. First thing I'm going to do is create a new folder for our project. I'll call it Space Battle, but you can call it whatever you want. Now in Atom, I'm going to open our folder so I can see what's in it on the left side of the screen. Let's make a new file and save it in this folder as index.html. This web page is going to have our canvas in it, as well as references to all our other JavaScript files and some assets later down the line. So here in Atom, if we just start typing HTML, it's going to recognize what we're trying to do, and then we can just hit enter, and it's going to fill in all the default HTML tags for us to save us a little bit of typing. The contents of an HTML file are stored as elements, and every element has an opening and closing tag, indicated by a /. For example, if you want to write a paragraph of text, you would use a P element, and whatever you write between its tags would be displayed as a paragraph of text. A few of the tags Atom added to our file aren't part of elements, but they give the browser a little more information about how to interpret our file. The first line tells the web browser what version of HTML this file is. Older versions of HTML had lots of different options in here to define different kinds of HTML files, but with HTML5 they simplified it, so now just saying HTML lets the browser know we want to use the latest version. The HTML element is the top level element that all our other elements go inside. Inside its opening tag, there's a few attributes, which are values associated with the given element that can change the way it's displayed in the browser. The first attribute tells the browser that our page is written in English, and the second specifies that our text is going to be read from left to right. The HTML element typically has two elements inside it, a head and a body, and then those two elements will each have a lot more elements inside them. The head takes care of setting things up before we actually display our web page, and the body contains all the information that we want to display. This meta tag gives the browser a little more information about how to interpret this file by specifying which set of characters to use when displaying text. And then the title element is going to let us change the title that appears in our browser when we open this page. I'm going to fill it with Space Battle, but again, you can call it whatever you want. So now we're going to create our canvas in the body, and again, we're going to start by just typing canvas, and then Atom will know what we're trying to do and fill it in for us. So Atom autofills our canvas with three attributes. One for an ID that we can give it, and then two to specify the dimensions of our canvas. This ID is going to be how we reference our canvas in JavaScript. And then I'm going to set our width and height to be 800 by 600, just so our canvas is a little easier to see. The next thing I want to do is add some CSS to make our canvas look a little nicer. CSS is another language that we can add snippets of inside our HTML files to give the browser instructions on how to format the content on our page. Web pages that don't have CSS look really boring. You might see a page without its CSS every once in a while if it doesn't load properly. We're going to use CSS to center our canvas on our web page and also add a border around it so we can tell where it is. We can include CSS inside our HTML files by writing it inside a style element. So we're going to add one in the head of our page. We need to tell CSS what kind of element we want to add styling for, so we'll specify that we want to add it to our canvas element. HTML uses tags to define everything inside an element, but in CSS, we use curly brackets. Any properties we change inside these curly brackets will be reflected across every canvas on our page. First, in order to center our canvas, we're going to set the position property to absolute. When an HTML file is being processed and its elements are being rendered to the screen, every element has a default position. This property tells CSS whether the element should be allowed to move from its default position or not. Its default value is static, which forces the element to stay in its default position, so we need to change it so we can move our canvas to the center of the screen. Setting it to absolute makes it completely ignore its default position and go to the very top left corner of the page, and it also allows us to use other properties to move it anywhere else on the screen. The four most intuitive CSS properties for moving HTML elements are top, bottom, left, and right. Whatever value you put in one of these properties will determine how far away from that edge the element will be drawn on the screen. A value of 20 pixels for left will place the element 20 pixels away from the left edge. A value of 20% for bottom will place the bottom of the element 20% of the way up the screen from the bottom of the page, and so on. We're going to set the top and left properties to both be 50%, so our canvas will be halfway across the screen and halfway down the screen. But this doesn't center our canvas. It centers the top left corner of our canvas. To fix this, we're going to add the transform property, which can do a lot of different things to change the way an element appears, but we're just going to use it to move our canvas up and to the left so that its center point is centered with our screen. The transform property uses matrix math to make its changes, so rather than specifying a single number as our value, we'll use one of many helper functions to return the matrix value we want. We just want to move our canvas, so the translate function will let us move our element by specific amounts in both the x and y directions. Again, we can specify either pixel values or percentages, but now the percentages are based on the width and height of the element rather than the entire screen. So by setting these x and y values to negative 50%, we can get our intended result by centering our canvas by its center point rather than its top left corner. Lastly, we're going to add a border to our canvas by setting the border property with 3 values. We're first going to specify how wide we want the border to be. I'm going to say 3 pixels, and then what style we want. And for that, I'm just going to say solid so that we have a solid line. And lastly, a color, we're just going to say black. This is all the real HTML and CSS we're going to need to write for this series, so let's save this file and test it out to make sure it's working properly. We could just go to our project folder and select our HTML file to open it in a browser, but due to security restrictions that exist in most browsers, viewing our game as a local file isn't going to let us access the full capabilities of our canvas. So in order to fix this, we're going to host a local server on our computer and use that to test our page. This is where Node.js comes in. We're going to use Node's package manager to download a simple package that lets us run a local server called HTTP server. To do this, open your games folder and hold down Shift as you right click inside this folder. Now we have this option to open a PowerShell window, and we're going to click on that. Let's make sure that Node is correctly installed and working by typing node-v. If you have Node installed, this will tell you what version number you have, and if not, it'll give you an error. Once we know Node's working, we're going to install our package by typing npm, short for Node Package Manager, install HTTP server, and then -g, which specifies that we want to install this package globally across our computer. This package works by taking a folder on your computer and treating it as the root directory of a web server and hosting that server on your local machine. We need to tell it what folder we want to run our server out of, so we'll say http server / to specify the folder that's open right now as the root directory and hit enter. This will start up our server, and you'll see here that it says it started our server on port number 8080. Now we can open our web browser and we can give it the URL of localhost:8080/index.html. If we open this, we'll have our canvas here centered in the middle of the screen, and it has a solid black border just like we wanted. Now that our canvas is working properly, let's start drawing things on it. I'm going to add a script element underneath our canvas. We could use this the same way that we use the style element in the head by writing JavaScript directly inside it, but this time I'm going to write our JavaScript in a separate file because we're going to have a good amount of code to add. We'll point this script element to another file using the source attribute, and we'll give it a file name of index.js. Let's make this file, and now we can start writing our code. First, we're going to need to reference the canvas we just made and store it in a variable. We need to give this variable a name, so I'll call it canvas, and then we can set its value using a built-in JavaScript function called document.getElementById. And inside, we're going to specify the ID of our canvas, which in this case is just canvas. In order to draw on our canvas, we need to retrieve its rendering context, which is an object that has all the drawing functions inside it. We're going to call it CTX for short, because we'll be typing it a lot, and we'll grab its value with the function canvas.getContext. And in the parentheses, we need to specify whether we want a 2D graphics context or a 3D graphics context. Now that we have this CTX value, we can access all the functions that let us draw on the canvas. So let's test this out by drawing a black square using the fillRect function. In the Canvas API, rectangles are defined by 4 values: the X and Y position of their top left corner, and then their width and height. The default fill color is black, so we don't have to change that. Let's just put in our 4 values for our rectangle. I'll say 100, 100 for the position, and 50 by 50 for the width and height. Now, if we save this and go back to the browser and refresh, we have our square. For now, this is going to be our player until we add graphics. So let's add a new file to handle the code for our player and call it player.js. Our player is going to be an object with functions and properties inside it. There's 2 different ways to create objects in JavaScript. We can use a constructor function, or we can use JavaScript object notation, or JSON for short. Constructor functions are like blueprints for objects we can create in the future, and JSON objects are only created once when they're defined. We're going to use both styles in this series, but for the player, we'll use a constructor function so we can have it stored in a separate file to keep our code a little more organized. So in this new file, let's make our constructor function. I'll call it player, and we're going to need curly brackets here too, so anything inside these curly brackets will be executed when we make our player. To add properties to the object this function will make, we can use the this dot prefix instead of var before defining the variable name. This is a keyword in JavaScript that points to the parent object of whatever part of the code it's called from, in this case, the inside of our player object. So now let's make our values. We're going to need properties for our player's X and Y coordinates, as well as their width and height. To set our X value, we're going to add a parameter to our constructor function. So whenever we call this function to make our player, we'll tell it what X coordinate to use, and that value will fill in this value whenever the code runs. Our player isn't going to move in the Y direction, so we can just set this value. I'm going to set it to 550. A value of 0 would put it at the top of our canvas, so this puts our player almost at the bottom of the canvas. For width and height, I'll keep the 50 by 50 that we had in our example. Now, to draw our player, we're going to make a function on the player object called draw. We can take the draw call from our index.js file and put it in here. Now we can change the values so they line up with our player. For the X and Y position, we're not just going to pass in our X and Y coordinates, we're actually going to do a little bit of math. Just like how our canvas was centered around the top left corner, our player would be drawn with its X and Y being in the top left corner if we didn't change anything. This would be fine if we were just drawing things, but since we're going to need to do some collision detection on our player later down the line, we're going to move the graphics so that the X and Y position of our character is at the center of where it's drawn. So for the X value, we're going to say this.x minus this.width divided by 2. And for the Y value, we're going to say this.y minus this.height divided by 2. The width and height values are just going to be this.width and this.height. Now, we can go back to our index.js file and replace that old draw call with some new lines of code. First, we're going to make a value that will store our player. I'm going to call it p, and it's going to be a constant. To make a new player object using our constructor function, we're going to use the new keyword and then call our function. In our parentheses, we'll specify an x value for our player. Let's just say 400 for now, to keep our player centered. After this, we'll add another line that says p.draw. This will call the draw function on our player object and draw our player onto the screen. One more thing we need to do is go back into our index.html file and add our player.js file. We added index.js in the body because it needed to reference the canvas in the body, but it's better to have your script elements in the head. So we're going to add our player.js script element up here. Now, after we save all these files and refresh, our player will be toward the bottom of the screen and centered. The last thing we're going to do in this first installment is make our player move back and forth across the screen. To do this, we're going to make a new file and call it input.js. This file is going to store the code that handles taking in user input. First, we're going to make a variable called inputs, and this is going to be an object we'll define using JSON. You write things a little differently with JSON. The object still has curly brackets around it, but all the properties are separated by commas rather than semicolons, and assigned using colons instead of equal signs. In here, we're going to list all the different kinds of inputs we're going to need in our game. These don't have to correspond to the keys that you press on the keyboard. You can name them whatever you want, but because all we're trying to do right now is make our player move left and right, I'm going to name ours left and right. This object is going to store all the different inputs we want, and it's going to have a Boolean value that corresponds to each to indicate whether the key for that input is pressed or not. Boolean values are just values that are always either true or false, so by default we're going to have both set to false. We need to tell the browser that we want to change these values when the key is pressed, and in order to do that, we need to use something called an event listener. Event listeners take in a certain kind of event they need to listen for as a parameter, and then let you specify a function to run when that event happens. So we're going to add an event listener to the window to listen for when a user presses a key on their keyboard. The name for this event is keyDown, so put that inside the parentheses with quotes, and then we can specify a callback function to run when the event occurs. This function doesn't need a name, but it does need a parameter that I'll call e that has information about the event stored in it, including which key was just pressed. To test this out, I'm going to just have our function print out the key code of the key that was just pressed into the browser console using console.log e.keycode. We can save this and then go back to our index.html, add input.js, save that, and then go to our browser and refresh. Now, if we open up our dev console using Ctrl-Shift-I or F12, you'll see that we have these key codes for the keys that we just pressed. Let's see what the key codes are for the left and right arrow keys. Left is 37 and right is 39. So now, knowing that, we can go back to our input.js file and make a new object called keybindings. This is going to store the various names we have in our inputs object and relate them to these key codes. So 37 is going to relate to left, and 39 is going to relate to right. In JSON objects, we can have numbers instead of words on the left side of this colon, and then we can access it by typing out the name of our object and then using square brackets to define the number. So the statement keybindings37 is equivalent to the name left. We can then use this whole statement as the name of a property in our inputs object and put this whole thing in square brackets. Now, this value of 37 is retrieving this value of left here, but then that value of left, which is equivalent to this whole statement, is now referring to the name of the property on our inputs object, and we're able to retrieve this value of false. Now, we can take that value and set it to true. Now, if we just replace 37 with e.keycode like we had before, this will work for any key on the keyboard. We're now going to take this whole block of code and repeat it again for the case where a key is released from the keyboard. This event is called a key up event, and all we need to do to change this is change it from true to false. Now we can save this and go back to our index.js file. Here we're going to add a function called gameloop. This function is going to take in a parameter that we'll call time, and this function is going to be the driving force behind our game. If you're not familiar with the concept of a game loop, it's a function that runs every frame and updates the positions and values of all the objects in the game, and draws all the graphics for the frame. The time parameter for our game loop is going to correspond to the current time when the game loop gets called, measured in milliseconds. We can use this value to determine how much time has passed since the last frame, and update any and all timers or positions of objects accordingly. To track the difference in time between this frame and the last frame, we're going to add a variable outside the game loop called prevTime, and that will store the time value from the last time the game loop was called. Inside the game loop, we're going to add a value called dt, which stands for delta time, delta being the symbol in mathematics that represents change. You can also think of it as difference in time, if that makes more sense to you. We'll set this to the current time minus the previous time, and afterwards we'll set the previous time to the current time so that on the next iteration of this game loop function, our previous time value will be updated accordingly. In order to call this game loop function every frame, we're going to use a function that's built into JavaScript called requestAnimationFrame, which takes in a parameter for a callback function, which is going to be our gameloop function. The requestAnimationFrame function will call gameloop and pass in the current time value, and because we have this call inside our gameloop, it's going to just keep doing this over and over and over again. We'll also need to add an additional call to requestAnimationFrame outside of the game loop, because otherwise the game loop function would never get called. When we're going through our game loop, we need to handle drawing everything that's going to be appearing on our canvas. We have our draw call to draw the player up here, but this needs to happen every frame, so let's move this down into our game loop. Now, As the player's X position is updated as the user holds down the arrow keys, the player will get redrawn in its new position. But the way we have it right now, the graphics that are left over from the previous frame would still be there as we draw our player again. So what we'd actually get is a trail of drawings of our character following its every move across the canvas. We need to clear our canvas every frame to give ourselves a blank slate as we draw our next frame, so we don't get something like this happening. To do that for now, we're just going to set the whole canvas to be white, and there's a canvas function called ctx.clearRect that can take care of this for us. In the arguments of this function, we specify a rectangle that will be the region of our canvas that gets cleared to white. We want to clear the whole thing, so we'll start in the top left corner, and then pass in the canvas's width and height, so that we can clear our whole canvas. Now we won't have a trail of our player's previous positions following behind it. Underneath the call to our player, let's add a call to another function on our player that I'll call p.update. This function will handle any updates to the player's position based on user input, and takes in our dt value as a parameter. Let's save this, and now back in our player.js file, let's add the update function. We're also going to add a speed value for our player that will determine how quickly they can move across the screen. I'm going to set it to 150, but you can change this to whatever you like. This value is going to be equivalent to the number of pixels that our player can travel across the screen in 1 second. Inside our update function, we're going to check the properties of the inputs object we made to see if either the left or the right arrow key is being pressed, and move our player accordingly. To do this, we'll use an if statement. If statements take a statement inside the parentheses that equates to a Boolean value. If that Boolean value is true, whatever code is inside the curly brackets after our if statement will execute. The properties of our inputs object are all Boolean values, so we can just name the input we want to check, and this if statement will evaluate to true if that inputs button is currently being pressed. So, if the left key is being pressed, we're just going to subtract from our player's X position to move it to the left across the screen. Just saying this.x minus this.speed doesn't change the value of our X position. We need to use an equal sign and set the value of the X position to the result of this expression. You'll find yourself in a situation like this a lot, where you're setting a value to itself, plus, minus, times, or divided by another value. So there's a shorthand operation we can do that'll give us the same results. The minus equals operator. This will subtract whatever we have on the right side from the value on the left side. We're also going to use our dt value to scale our speed to be in pixels per second rather than pixels per frame. We're going to duplicate this statement to handle right arrow key input. And now we just need to change this minus equals to a plus equals. So that's all the code that we have to write for this installment. So make sure that everything is saved. And now if you go back into your browser and refresh, you should be able to move your player to the left and right across your screen using the arrow keys. You can tweak your speed value up or down to see what it looks like when the player moves at different speeds, and find a speed that you think feels comfortable. That's all I'm going to cover in this installment of the series. Feel free to leave a comment if you have any questions about the material I covered, and I'll try my best to answer them. If you're having trouble getting your code to work, you can download the source code for this tutorial from my GitHub repository. I'll have a link in the description, and once you're there, all you need to do is select the branch for part 1 of this series, and then hit clone or download over here in the right corner, and then hit download zip. In the next installment, we'll start adding bullets and enemies that shoot back at our player. Thanks so much for watching, and I'll see you next time.